Okay, let's dive into this. If you've ever shipped an LLM-powered feature, you know this feeling deep in your bones. The demo works like absolute magic. You push it to production, you celebrate, and then it all comes crashing down. So today we're going to walk through exactly why that happens, and more importantly, the production-ready playbook to make sure it never, ever happens again.
Ah, yes, this old friend. You wake up, you check your Sentry dashboard, and it's just a sea of red. This single error message is, without a doubt, the ghost that haunts every developer building with language models. It means your perfect feature is now completely broken for users, and the cause is almost always simpler and way more frustrating than you'd think.
And there it is, the culprit. The model just decided to be a little too conversational. A friendly preamble, maybe it wrapped the code in Markdown fences, or, my personal favorite, a single trailing comma. And that's all it takes. That's enough to crash a standard JSON parser and bring your entire feature to a screeching halt. Welcome to the world of almost-JSON. So what's the real problem here? What's fundamentally going on? Well, a language model doesn't think in data structures. Not at all. It just predicts the most probable next word or token over and over again. And yeah, it's seen a ton of JSON, but its core training is to be a helpful assistant, which means it can easily drift back into natural language. You can't just slap return only JSON in your prompt and cross your fingers. That's not going to cut it in production. This needs a real engineering solution. So here's the solution. We need a defense in-depth strategy. This is the playbook. It's a 3-layer fix that builds true resilience. First, we're going to force the model's hand with native schema enforcement. Second, we're going to validate the meaning of what it gives us. And third, we're going to have a fallback loop to repair and retry for those stubborn few that still manage to fail. All right, let's start with layer 1, which is by far the most impactful. I'm not kidding. This one change will get rid of the vast majority of your errors right off the bat. Every single major model provider, OpenAI, Anthropic, Google, they all now offer a way to constrain the model's output to a specific schema. If you do nothing else from this entire explainer, please do this. OpenAI's version is it's so elegant. Look at this. You can pass a Pydantic model directly into the response format parameter. The API then literally forces the model to generate only the tokens that fit your schema. And the result? You get a fully parsed, typed Pydantic object right back. No more manual parsing, no more chatty preambles, no more junk. It's beautiful. Now, Anthropic's Claude models get to the same destination, just through a slightly different mechanism. Here, you define a tool with the schema you want, and then you use tool choice to force the model to call that tool. The model has no other option but to fill out the arguments for that tool, which means, you guessed it, you get back perfectly structured, schema-compliant JSON. And over at Google, Gemini follows a very similar pattern. You set the MIME type to JSON, and you provide the schema. The rule of thumb here is super simple. If the API you're using has a native mode for structured output, you have to use it. It is always better than trying to bully the model into correct formatting with just a prompt. Okay, let's move on to layer 2 and see how this all stacks up. So native enforcement gives us syntactically correct JSON. The brackets and commas will be in the right place. But, and this is a big but, it does not guarantee that the data inside that JSON actually makes sense. And that's where validation comes in. And this right here perfectly illustrates the difference. Layer 1 asks, is this valid JSON? But layer 2 asks the much more important question, does this data actually make sense? Because the model can still hallucinate a founding date of the year 1, or use a string where it should be an integer, or just return null for a field that you absolutely need. Pydantic is our shield against this bad data getting into the rest of our application. And this is how we do it. We define our Pydantic model with really strict validation rules. So here, for example, we're making sure the founded year is within a reasonable range. Every single LLM call in your system should return into a model just like this. The mindset shift here is absolutely crucial. Treat the LLM like any other unreliable third-party API that you just don't trust. So for about 95% of your calls, the first 2 layers are going to be enough. You're golden. But for that last 5%, the weird edge cases, the super long inputs, or those moments where the model is just having a bad day, we need a final line of defense. And that is the repair and retry loop. Before we completely give up on a failed response, we're going to try to fix it.
There's this fantastic little library called JSON Repair that acts as a super forgiving parser. It can handle so many of the common syntax errors that a strict parser would just immediately reject, like those pesky trailing commas or using single quotes instead of double. It's just a really pragmatic way to salvage a response that is almost correct.
Now, if the repair fails, we don't just retry blindly. That's pointless. Instead, we do something really clever. We take the validation error we got from Pydantic, we append it to our prompt history, and we ask the model to fix its own mistake. And this is incredibly effective. It turns out LLMs are surprisingly good at self-correction when you give them specific, structured feedback on exactly what they did wrong.
So what happens if even the retry loop fails? This is where a critical software engineering principle comes in. Don't just raise exception. That's a dead end. It tells you nothing. We need to fail with typed, structured exceptions so the code that called our function knows exactly why it failed and what it should do next.
For instance, we might raise an insufficient data error. This means the model did its job perfectly, but the information we were looking for simply wasn't in the source text. This is not a 500 server error. This is a piece of information you can actually show to the user, like, sorry, we couldn't find a founding date in this document. That's a good user experience.
On the other hand, a schema violation? Well, that's a real problem. This means that after all our layers of defense, the model still couldn't produce valid, structured data. This error should absolutely trigger your logging and send an alert to the engineering team. It's a huge signal that your prompt or your schema needs some serious investigation.
So let's put it all together. What does this look like? We wrap our 3 layers into a single clean entry point. The rest of our application doesn't need to know a thing about JSON or retries or validation. It just calls one function and it gets one of 2 things back, either a fully validated data object or a specific typed exception it can handle gracefully. Clean, right? And here's a little cheat sheet for you to take with you. Depending on which model provider you're using, whether it's OpenAI, Anthropic, Gemini, or even a local model, this table shows you exactly which structured output method you should be using. This is your quick reference guide for implementing Layer 1 correctly every single time.
If there's one thing you take away from all this, let it be this. We have to stop thinking like prompt hackers and start thinking like software engineers. The solution isn't some magic prompt. It's about treating the LLM as just another component in a system, an often unreliable one, and building robust defensive layers around it, just like we would for any other upstream service.
So there you have it, 3 layers. Each one catches what the previous one missed. You ship that, and your error alerts, they finally go quiet. Your Sentry inbox is empty. So the only question left is, with all that time you're not spending on bug fixes, what amazing new feature are you going to build next?
If you found this helpful, hit subscribe and the bell so you never miss a video.